Number 10, the graph of a function h of x is shown. Draw a graph that would represent g of x equals h of x minus 3 plus 2. So here's the graph h of x is shown. And we want to find g of x if these transformations have occurred. Now let's think about transformation rules. We have two rules. We have HIVO, which means horizontal is inside, vertical is out. So horizontal inside, vertical outside. Secondly, we also have the other rule about that horizontal is backwards or opposite, and vertical is normal. Okay, so let's come over here. What I see happening on this equation is that we have minus 3 in the inside. Since it's inside, it's horizontal, and horizontal is always opposite or backwards. So instead of going horizontally negative 3, we're going to go right 3 units. Everything gets right 3. This over here on the outside, well, obviously it's saying it's outside, it's vertical. This is vertical, it's going to be normal. So this is going to go up 2. So if I take any point on there, I would draw it right 3 units, up 2 units. So here I would go 1, 2, 3, 1, 2, and this point's going to be there. If I took this, it would go 1, 2, 3, up, and 1 and 2 will be up here. So I move this point, I move this point. You can try this one. We go 1, 2, and 3, up 1 and 2, somewhere right in there. And so this new graph would come, and so these basically are the same thing, it's up. So if I took any of these, let's see, it looks like it crosses right here. Go 1, 2, 3, up 2, would be like right in there. And I'm going to erase this so I don't get confused. So this is my graph. So we come this way. So these would be shifted the same thing, right 3, up 2. So if you took any one of those, we'd have right 3, up 2. So this graph is coming in like this. It's that point. Then it hits this right here. And at this point, it curves back around up. And hits this point. And then it's going to curve down. And we can figure out exactly where it crosses through. I should have done that. This point looks like it's about right here. 1, 2, 3, up 1, 2, which I actually drew all right. And so it comes, it hits this point, and then you curve back up. And let's see, where does this cross? It doesn't even cross, so it go up really, really narrow this way, like that. That's how this graph would look. Now, if we had an actual equation for this, what we could do is in the calculator, if you had an actual equation, let's just say, for example, you had that f of x equals x squared, and you're supposed to find g of x with the same transformations. What you could do in the calculator is you could put that in as f1 of x, and then f2 of x, you could say is equal to f1, and you would put this in there, x minus 3, and on the outside plus 2, and this would graph it exactly if we knew the starting equation, which we don't know right now, but that's how you could do it in the calculator.